So this is where we stopped. Alright, so here we are looking at what we call compound if statement, or compound means we combine the few statements, right? And or if one situation and then there are a few other situations related to that. For example, we call this a nested if. Right? For example, here there are two situations. One is if country is USA, the other is if country is not USA. So this is correct, but it will be easy to check that we have put braces around our if-else statement. So here, if the country is USA, we check whether it's Alaska or Hawaii, because currently these states have different kinds of shipping rate, 0.5, right? Otherwise, it's within USA, but the shipping rate remains at 0.33 for shipping to continental, meaning to say that within US or within the same continent. So currently US is a continent, right? So here, as you can see, the first brace right after USA, right, will be, this is the opening brace, and it's closed by the brace right before the last else here. Right? So opening and closing, and within these two braces we have two if situations. First is if state is equal to Alaska or state is Hawaii. This is the first if. Then else. So what happens is that we decide whether the country is USA or not. Then we decide whether the state is Alaska and or Hawaii or not. If not, then shipping rate 0.33. If country is USA and state is Alaska or Hawaii, then the shipping rate is 0.5. Else, if the country is not at all USA, then the shipping rate is 0.75. So, but you know, arranging the braces in a in an aligned manner might help you a lot. For example, if you put this brace here and here, then you know that this is, you know, the whole thing is under this if, right? Same thing, same goes with this and that. Or you can have, because it's just one statement, right? After state Hawaii, it's just one statement, you actually don't need the brace, right? So maybe you can decide not to have it if it's just one statement. So yeah, your braces can help you go through your codes really quickly or not. Right? So be careful when comparing decimals. Here is double R square root. Here is just you can see logic, right? Because here this will actually output nothing. It should output something because double R is equal to square root of 2, right? R is a double. That means it's a rather precise float, right? And it's a square root of 2, so if we multiply it together, meaning if we square it, we should get 2, right? So if R times R is equal to 2, which it should, right, then output should be R squared is 2, but it outputs nothing apparently, even though it should. This is due to the round of error, meaning to say that square root 2 times square root 2 will actually get something like this, which is not exactly 2. So one solution is to check if answer is really, really close to 2. For example, you can use something like this one. So this is with regards to very precise programs, right? Or you can use other solutions like if absolute, right? So absolute, and so on. Alright, so more than, less than, equals for string, but it's a little tricky. So you can use something like that. In fact, there might be some weaknesses or things that cannot be run with regards to the emulator we are using. Right? Something lexicographic order, like in a dictionary. Numbers come first, then uppercase, letters, and lowercase, 1, 2, 3, then abbreviation, then ABC, and so on. Right? So if string name is Hobbit, so if it's exactly Hobbit is true, if capital H is there, it will be false. So it's what we call it case sensitive, meaning to say that we have to type it exactly the same, because computers see words differently from us. Meaning we see a word oh, this is the same word, we accept it. Computers cannot do that. Right? So it's case sensitive. If you change even just one small cap to capital letters, it will technically will take it as two different things. If name is equal to name less than 2, name less than 2, and so on. So one is where the name is not 2, this is Hobbit. Right? So this will give a false, whereas here we cannot do it like this because name is a string. So you cannot equate a string with a number. Like here we're trying to do something logical with it, meaning we're trying to say that name is something like a number and we're testing whether it's less than 2. It's like say because name here is a string, so we cannot actually compare it with a number like this, right? An operable number, which is 2. Right? So let's have a look at these statements and see what's wrong with them. Right? So if x is equal to 1, see out x. So what's wrong with this statement? Right? So we have 1 less equal sign. Right? Here, if we do like this, 1 will just be a sign x. Right? What about this one? Doesn't break. This one is just a matter of first we don't have the brackets, and then I'm not sure whether we can have that, but generally we do not use that. Right? So it's just brackets. Some programming languages and or some compiler might use that, but I don't think so for C++. Right? So one is the bracket, the other one is the then. We don't need that. Right? So if name equals John or John. So here it's pretty simple, right? So we're missing the that vertical symbol. Right? Missing that John or John. See out name. If x and y is equal to here, we should be doing this. It should be n and we should be doing it for both sides like that. If x is equal to 0 and n, y equals to 0. X equals 0 and y equals 0. Hi John, how are you? So here is you can see it's a questionable kind of error. It's not necessarily an error, right? But taking into consideration the whole thing, maybe it's a slight error. It's a logical error. We call it logical error because the code won't say you did something wrong. Meaning the compiler won't pick this up. It will still run it. It's just that we consider that this programmer actually wants both of these to be associated with that condition, right? So this should be a compound statement within braces. But then it's a 50-50. Maybe the programmer wants to say hi John if it's a John, but then say how are you, regardless of who it is. Right? So it's a 50-50 kind of thing, right? But if it is meant to, if this statement is meant, how are you is meant to actually greet John, then both statements, hi John and how are you, should be within braces, the curly braces. Alright. So this is another way of doing if. We can use what we call switch statement. Right? Here's a sequence of if-else statements with a switch statement. I'm not very sure, but this is, I guess to a certain extent, it's a matter of preference. Switch can look very systematic, it can look very neat and tidy. As you can see, it's very consistent, So basically, we're just checking, let's say for example, if x is equal to 0, what happens? X is equal to 1, what happens? And so on. Let's say for example, x is equal to 0, then something. So what we do is, let's say we have the variable x, switch x, case 1, break. Case 2, break. Case 3, break. So it's similar to say, if x is equal to 1, all this. If x equal to 2, all that shall. so on. Right? So if variable is equal to if variable blah blah blah, then something. Variable blah blah something. Right? Whereas here is a switch like this. I'll try and show it. Oopsie. Try and show an equivalent statement like yeah. But for that I have to clone display first. Right, so I'm just gonna put this as comments. Right, so if x equals 1, then 1 1 1. So this is a what we call a pseudocode like yeah. X equals 2. Then a pseudocode is a an almost programming language, meaning it's like a logical statement. It's not really, it doesn't really belong to any programming language per se, right? So I'm just going to do this, right? So this is equivalent to this switch statement, right? Switch x, right? Case 1, one, right? Case 2, 2, 2, 2, right? So these are equivalent, right? So if x is equal to 1, then it's 1 1 1. If x equal to 2 on the other hand, then 2 2 2. It's the same as doing like this. Switch x, case 1 1 1 1, case 2 2 2, and so on, right? So one might look to me it's a matter of preference. I can't really say which is better for what. I mean, it's equivalent kind of statement, and obviously both exist because of that. It's personal preference, right? But in my case, because I was introduced to if first before switch, so I prefer if. So you might have a different kind of preference. So just a little bit more. So don't forget the break. Compiler won't catch it. Meaning break means once done, you can go to the next one. So you can do away with the curly braces, right? You can check multiple values by stacking the cases, case 1 and 2, and then statements. So you can have the same statement for the same case. So yeah, it might be simpler, might be neater, right? Switch statement is particularly good for setting up menus. So it's a menu kind of thing. Suppose we want a basic calculator, for example, enter two numbers, 2, 3, add 2, 1, add 2, multiply, 3, divide, choice 3, and automatically it does that. So you can add value to a particular logical structure and or logical structure of your program. After you set the I mode to get integers x and y, switch statement can implement your decision nicely. So this is as opposed to on the right hand side, you can see this is if you're doing it with if, whereas here if you're doing it with case. So it might seem neater because again you can see the each case clearly as opposed to if. Right? But then again, see, it's neater. That's what I see. That's what I see how it adds value. It's quite neat. So you see, unfortunately, it only works on integer and character data types, right? You cannot, for example, use it for strings and so on, right? We could handle a single letter response with a character, right? So character response and so on. Case Y, where we can use something like this for your addition, multiplication, and so on. The first challenge that we have, right? Right, program to display the total price of movie ticket based on the day and the number of ticket entered. Here I'm not really sure because this is the original slide. I'm just not really sure what how we actually go on and calculate this. Day 3, number of tickets, 2, price is 14. So where did the 7 ringgit come from actually? Day 3 is there a moviegoers? Is there like a formula for movie tickets like that? I'm not really sure. I mean,